So here I've got the Lascelles Polaroid Analyser, but what does it do? How do we use it? Let's go. So this is a small handheld device. We've got a solid acrylic base for holding, and then on top of that we've got these two Polaroid filters which are fixed in place. The filters are oriented in such a way that they're not letting any light through. So let's just talk about what's going on there. So a Polaroid filter is essentially just an array of straight parallel lines whose job it is to only let a certain type of light through it. So the condition for light passing through the filter is that its electric field vector has to be oriented in the same direction as the lines on the Polaroid. So let's say, for example, if the Polaroid has its lines all in the vertical direction, then the electric field vector of the light also has to be oriented in that vertical direction. So what's going on here? Well, we've got one Polaroid in the vertical direction and another one in the horizontal direction. They're at right angles to each other, and this condition is known as CrossPoars. So just to be clear, what we've done is we've got one Polaroid oriented in the horizontal, one in the vertical, and this is making sure that no light gets through, which is why this appears dark. Now, if I hold this at a slightly different angle, you can see some light on the Polaroid. Now, that's not transmitted light, there's no light source behind me. This is reflected light from the rig that I'm using to take this video with. So to convince you of that, here I have got a really bright light source. If I hold that behind the Polaroid, you can see that absolutely nothing is getting through. Physics is magic. So that's what this piece of equipment is. How would you use it in your classroom? So this is a really nice little demonstration of something called photoelasticity, which is the posh way of saying looking at stresses in a sample as they undergo deformation. So this piece of equipment comes with this little sample. It's got these two ears here which you can push together and introduce some stress, and the idea is you place it between the two Polaroids, give it a squeeze, and I can see some really nice patterns on my side. What I'm going to do is take you over to the light so that you can see them too. The accessory pack for this piece of apparatus is the stress structure set, and this comes with 4 extra shapes that you can have a go at squeezing. It also comes with 2 other pieces of plastic that the teacher or the students can use to make their own shapes with, to make this demo a bit more engaging. So let's have a look at what some of these things look like under the light. So now we're at the point of explaining what on earth is going on here. So if we ignore the sample for the moment and just take the apparatus as it is, we can say that if we have a light source here, it will hit the Polaroid, which cancels all the vertical, hit the analyzer, which cancels all the horizontal, and we are left with no light coming through. Then if we introduce our sample in the middle and squeeze, all of a sudden we get light through again. So the only logical explanation for this is if, as soon as the light hits the sample, it's actually going to change that tilt on the electric field vector as it passes through it. And that's exactly what we're seeing here. It's a phenomenon known as optical rotation. Now, optical rotation is also the principle behind polarimetry and polarized light microscopy. And those are 2 widely used techniques in physical chemistry, so it's a nice tie to another science. And also, it's a perfect example of some real-world application of polarized light. So that's how we explain the light coming through the Polaroids, but we're not just going to leave it there. As we squeeze the sample in the Polaroid, you can see that we get these beautiful interference fringes, and that is due to the sample being birefringent, which essentially means it's got 2 refractive indexes. So as light travels through it, it's going to be traveling at 2 different speeds along 2 different pathways, different phases, so that when light comes out of it, all of that light is going to interfere with itself, and that's where those interference patterns come from. So would you actually use this technique in industry? The answer is absolutely. It's a really quick, effective and cheap way of understanding what stresses you've induced in your sample by passing it through industrial processing conditions. So sample stress can be induced from a variety of different procedures such as extrusion, moulding, stretching, and it's really important to understand how we're affecting the sample by doing that. It'll give us a clue to material lifetime, its weak points, and what its limitations are. So in all, this is a really nice affordable little demo which is going to take your optics demonstrations of polarized light to the next level. It's all very well and good to understand what polarized light is, but until you apply it to something and talk about how we exploit that understanding, that is where it gets really interesting, and that is where you're going to hook your students, and especially with this one because it's super, super pretty.